The content herein is for informational purposes only, not intended as medical advice, diagnosis, or treatment, and is not to be substituted for direct advice from your doctor.
Today's LymphCast program is proudly sponsored by VitaSupport MD, the makers of Vein Formula 1000 and Lymphatic Formula 1000. These MPFF-based nutraceuticals are backed by science and recommended by doctors specializing in venous and lymphatic disorders. Visit VitaSupportMD.com to learn more.
Welcome to LymphCast, the show that brings together doctors, other health professionals, and special guests to discuss lymphedema, venous disease, and other associated disorders, and what can be done if this is affecting your life. Now it's time to sit back, relax, as it's time to learn all about lymphedema, venous disease, and associated disorders on our show, LymphCast. Greetings and welcome to LymphCast, episode 17. Glad you're with us, whether you're watching, listening, or both. Let's go ahead and meet our panel, and we'll get right down to it tonight. The founder of VitaSupport MD, which makes Vein Formula 1000 and Lymphatic Formula 1000. Also the founder of the LymphCast show that you're listening to and or watching right now. From New Jersey, surgeon, physician, Dr. John A. Chuback. Greetings, Dr. Chuback. How are you, sir?
Greetings, Paul. I'm doing well. Looking forward to today. Our guest, we have had a few technical issues and weather-related issues and so forth, and we have been waiting for today's special guest for some time. So without further ado, I'm going to pass it back to you so that Mark can make his introduction, and we'll say hello to Dr. Iker, too.
Okay, yeah. Greetings to Dr. Emily Iker from California. How are you tonight?
Hi, wonderful team and all the participants. Greetings from California. And today we don't have rain, so I think we are expecting a wonderful session with our wonderful team.
All right, very good. And from Minnesota, Dr. Mark Melin. First of all, greetings, sir. And then after you say hello, if you'd kindly bring in our guest, that'd be great.
Good to be here, Paul. It's a wonderful day, and we're so fortunate to have Professor Sunny Narayanan from Florida State University. And I first met Sunny about a year and a half ago. I was fortunate enough to be on a space forum or seminar, and Sunny and I got put in the same room. And as I sat there and listened to Sunny's background, the research he was doing, what he was looking forward to doing, it was very enthralling. It was incredibly educational, and Sunny's really one of these individuals within the United States that has a unparalleled and unmatched research background and a vision that will help improve human safety in the field of weightlessness within low Earth orbit and beyond. So with that, Professor, I'm going to bring you on, Sunny, and let's just hear a little bit about your background and what sets the stage for what we're going to talk about that you're getting ready to do.
Absolutely, Dr. Melin. Thank you so much for the introduction. It was really an honor to meet with you at that event, and the opportunity to chat about space health is a subject matter of a great of interest and passion with me, but also an opportunity to connect the space research industry with circumstances here on Earth. And I think lymphatics and medical research is a great connection between NASA and the space industry and the healthcare industry that is perhaps overlooked. So I'm really delighted to chat about those direct, indirect areas, and to show a bit about myself. I'm a research faculty of Florida State University, specializing in space and medical physiology. I'm also very proud to be a first-generation academic. I'm the first in my family to go to college, first in my family with a connection to NASA, and first in my family to pursue a PhD, and first in my family now to be a professor. And my interests to be a professor were even before I first took steps in college, recognizing how education can really change the direction and open opportunities and so many doors that in retrospect, I had no idea even existed. And that's really the beauty of education, I think. and also my journey connection with lymphatics. As an undergraduate training, I was a double major in mechanical engineering and biology. I had the initial spark to be involved with NASA as a rocket scientist, rocket engineer. My first projects with NASA as an intern in high school and throughout college were in those areas. But I had this fascination of biology in the background and medicine. And through my undergraduate journey, I thought, ironically, given how I started, how these are separate worlds. But in fact, NASA and the space industry has a lot of interest with regards to how people adapt in space and how biology adapts in space. So I had the opportunity to make that connection and then pursue my graduate degree at Texas A&M in the lab of Dr. David Zavea, a lymphatic researcher many years. And my connection with Dr. Zavea was also serendipitous, where even though my biology physiology background and from my undergraduate training, I was exposed to cardiovascular physiology, I was exposed to immunology, but not lymphatics. So I joined a graduate medical physiology program, discovering lymphatics, and I thought, wow, this is just incredibly interesting and intriguing, that this part of the circulation that has so many diverse roles and interactions with so many different organ systems, that again, this door just opened for me. And in short, I really had a great privilege to continue my training in the lab of Dr. David Zavea and be involved with both NASA space health projects and medical research, lymphedema, various autoimmune conditions. I'm just really delighted for the opportunity to meet with you all tonight and talk science.
Now, one of your specialties is galactic cosmic radiation and the impact on lymphatics. And when you talk about translatability from what you're doing in low Earth orbit, that radiation impact on lymphatics, I'm sure you can see some manners in which we might be able to better protect patients that have cancer and have to go through radiation and chemotherapy, because like we were just talking about with Emily Iker, patients that have had past cancers, get chemotherapy, get radiation, certainly can end up with a much higher rate of lymphedema. So tell us a little bit about that work you've been doing with galactic cosmic radiation and lymphatics, and what you see as how that potentially will play out in helping us better take care of patients.
Thank you. Thank you for bringing up that discussion point. I've had various research studies investigating galactic cosmic radiation as a factor that the astronauts, when they travel to space in different locations in space, they will experience different levels of galactic cosmic radiation. The astronauts on board the International Space Station currently, as well as those that have traveled on space shuttle and were on board Mir, and now with the commercial crew with SpaceX, those astronauts have experienced galactic cosmic radiation, which is different from X-rays or light-based radiation, photon-based radiation. It's more similar to particle radiation, so carbon therapy is a closer comparison to galactic cosmic radiation. But galactic cosmic radiation is different in a few additional ways. It's not just carbon; it's from hydrogen all the way to iron, heavy iron, and also the doses are much less compared to what patients may experience from therapy, and also the dose is whole body. Astronauts experience the whole body radiation exposure, as well as chronically. Whereas in clinical setting, it's generally acute fractionated doses. So there are a few differences to consider, but there are some comparable biological observations and adaptations, and perhaps even mechanisms that we could certainly learn from GCR studies. And one other quick note is that we're really learning the significance of GCR when we think about the Apollo astronauts and how there's been suggestions that the Apollo astronauts, the only astronauts that have traveled beyond the magnetic field of the Earth, and thus been exposed to more galactic cosmic radiation, space radiation, than any other astronauts. They have suggestions of heightened risk of cardiovascular disease. whether they also have increased risk of lymphatic lymphedema, we really don't know. The GCR area of research is really just at the tip of the iceberg, so to speak. And so is lymphatic research in general in the space context. Astronauts have been observed to exhibit fluid shifts and changes in the appearance of there's a puffy face syndrome where their faces are appear edematous and chicken legs is the term that they use for their legs having been shrunk in size. So there's observation certainly of fluid distribution, and that's been primarily hypothesized to be driven by gravity differences. So GCR is definitely a very interesting and relevant new factor because could from what we know with regards to radiation effects on lymphatics, which have been shown to increase susceptibility of developing lymphedema, does that also GCR exposure, does that heighten the risk of astronauts developing lymphedema or lymphatic associated conditions? And really just the tip of the iceberg.
And you had mentioned, because Mike Delp, of course, is at Florida State University, and you know Mike well. He wrote that kind of pivotal study, I think, in 2016 about the extra exposure to the Apollo astronauts, and they seem to have a higher risk of cardiovascular disease. Of course, Irwin passed away early, age 56, from cardiovascular disease. Neil Armstrong eventually passed away from cardiovascular disease at a later age. So, you know, from John Chuback's standpoint as a cardiovascular surgeon, it's kind of interesting because the lymphatics now have been directly connected to cardiovascular health. And we've seen that in multiple publications. So we always think about arteries, but really lymphatic impact in terms of migration of lipids and impact on immune function, because immune function is a big part of organ health. So, you know, John, it goes back to speaking that, and you pointed this out many times, as is Emily, the lymphatics are vastly under-recognized in terms of systemic cardiovascular health. And I'd be interested to hear your comments on what you think in terms of improving lymphatic health can maybe help systemic cardiovascular health in the long run for our demographics.
Well, I have to be perfectly honest. I mean, that's an area that I don't have a significant amount of personal knowledge in. I mean, I think I'm still sort of from the old school or the old camp that there are many notable risk factors for coronary artery disease, you know, the classics being genetics, family history, obesity, smoking, high blood pressure, hyperglycemia, diabetes, etc. Though this is a fascinating subject of how the lymphatic system may or may not affect lipid pathophysiology at the level of the endothelium, etc. But I have to be very honest with you, Mark. That's fairly uncharted territory for me in my knowledge base. But it's a really, really interesting subject.
Well, I think where it's uncharted for all of us here on Earth. It's with the astronauts in space, it's almost like an aging situation. When they're on station, and Sonny, you're going to fill in these details because you know them so much better than anybody. When they're on station, they age faster. So you almost get to watch in real time these proteomic shifts and these changes in bone health, changes in cardiovascular, arterial stiffness, etc. And so as Sonny's doing this just absolutely foundational critical work on what happens to lymphatics in space, we're going to be able to take back that information and understand then how we see our patients age in front of us over, say, a decade, while we're watching it change in real time much quicker on the station. And many of those studies have already been published in terms of that kind of aging phenomenon, correct, Sonny?
I guess my question there, to jump in before Sonny answers, I guess my question there would be twofold. One is, how much of that do you believe to be a direct you're calling it galactic cosmic radiation, GCR effect on the endothelium and the media of the vessels, as you would see in the old traditional models of a direct impact. And the second question is, what, if anything, can be done or has been done to shield astronauts from this GCR?
Yes, on the context of the spaceflight environment does provide an environment to study how physiology adapts in very dynamic and very accelerated manner, and many of the adaptations have been are comparable to an accelerated aging phenotype, which is highlighting how, unsurprisingly, how significant of an environmental factor gravity is. In the context of GCR, we'll learn a lot more, in particular once we, with our Artemis project, return to the moon, where based off the modest observations that we acquired through the Apollo program, and through the work by Dr. McDowell and Frank Cucinata and various NASA researchers have identified how even just a few days around the moon, with exposure to deep space radiation, there may be some suggestions of differences. And we're learning that as individuals stay longer in space, then there are even more differences. So physiological adaptations and space shuttle astronauts experienced are different from astronauts that have been on board space ISS for 4 to 6 months, and now we're learning it's also the case with astronauts that are staying as long as a year. Still in the confines of low Earth orbit, so not as much GCR exposure as they would on the moon. That's where research is highlighting that there are deep space radiation effects that we're learning will help us prepare and give us some insight in terms of what our astronauts, when they travel to the moon, what they may experience. And then also in the context of shielding, the best shielding is actually spending as little time in space or in the presence of, say, if we're talking about a trip to Mars, getting to Mars as quick as possible is the best form of shielding, and then being in the presence of an atmosphere and being shielded that way. So when we think about shielding in a habitat around the moon or on the surface, it's going to borrow very much with what we've developed with the International Space Station. So that's a really a technology development question to minimize the kind of adaptations that crew will experience when they're on the moon.
But currently there are no materials that the ship itself can be sort of reinforced with or lined with to stop this form of radiation. It penetrates everything. The
most effective currently we know of shielding the radiation is water. The water's relatively it's dense, it's heavy. Thankfully, there's suggestions of water on the moon, so that could be a resource harvested on the moon to then acquire for water is vital for many different things. So in addition to shielding,
I've heard that about water. Valuable. It'd be a good resource to have plenty of on the moon if you wanted to stay a while, I would think.
That's right.
Well, the nice benefit is it can be turned into hydrogen and oxygen, which also can be a fuel element to get the ships back off the moon at the end of the day.
That's right.
It's interesting you mentioned that about water shielding, because I remember reading the astronauts that had to stay on the station longer after the Columbia loss in 2003. I think the astronaut's last name was Pettit. And he would always go and sleep against the wall of water that was in the station to try to decrease his overall exposure, because he wanted to return to space again later. And and correct me again if I'm wrong, Sonny, but once you reach a certain cumulative dosing, they won't let you fly again potentially.
That's right. That's there is a an occupational hazard requirements that NASA does and space agencies do recognize for the health of astronauts, but they are of course very they get creative and are very much appreciate the opportunity to fly into space. So um, that's where research and development of new materials. So research, space research provides a mechanism for discovery and innovation, designing and developing new materials that could be applicable for, say, nuclear plants here on Earth, or new therapies that improve mitigate ameliorate the adaptations that occur from spaceflight exposure that could improve medical conditions here on Earth. One example in the bone research that bone there have been studies using bisphosphonates, which binds to the osteoclast in bone and it improves regains bone reduces bone loss, so to speak, and that's been tested with that's planned to be tested with crew to see if that ameliorates some of the bone loss that is occurring, and in turn the bone loss that the crew experiences at a much faster derivative speed rate than any medical condition here on Earth. So it provides, unfortunately for the astronauts, but as they're willing to take the risk to continue to stay in space, but it provides a mechanism for discovery and innovation in many different ways.
Vein Formula 1000 and Lymphatic Formula 1000 from VitaSupport MD are backed by science and sold in doctors' offices. If you're a physician who may be interested in prescribing or selling these excellent nutraceuticals, please call 862-246-7877 to speak to a representative today.
We're going to pivot to one of Emily Iker's areas of expertise, both national as well as international. It's how to use an ultrasound probe. And you're doing this really phenomenal work on veins. And we know that there was a DVT event in space in 2019, I believe. And, Emily, there's people that get to do these parabolic flights where they're in an airplane that goes up and down like a roller coaster. So if you had the opportunity to try to do ultrasound in a parabolic airplane, would you take them up on that offer?
Interesting question. I think it would be interesting to do the baseline study and then compare, see the differences, and then you will have objective proof of possible changes.
Have you had a chance to do a parabolic flight, Sonny?
Yes, I have had the opportunity to fly and launch launch experiments and fly on board the Weightless Wonder NASA calls the parabolic plane, and it is certainly another unique environment to conduct research experiments. And there have been some studies by Ben Levine's group in Texas. I'm unsure if they've done ultrasound. Likely they have, but those are certainly another way to measure acute cardiovascular adaptations to microgravity and see. So the venous thrombosis events are different from parabolic flights, where we're seeing now that astronauts may have their cases of venous embolism. And that may be, there's so much we still don't know about that as well.
So tell us about the research that you were just awarded. I'm looking at the NASA Space Biology adaptations to spaceflight environment, and one of your areas that you're going to be researching is looking at how veins function in different organs in the space environment.
Absolutely. Thank you for mentioning that. With regards to going back to your earlier conversation point and how cardiovascular research may be focused on arteries and may not be integrating all these components of the cardiovascular system, that the heart driving transport of blood through the arteries, the distribution by the capillaries into the interstitial tissues, and then collection of blood and lymph by the veins and lymphatics. And as an engineer, I think of it very much as from a systems engineering approach, and how these different components adapt and complete their physiological function, but they're connected, not just structurally but also functionally. So the why I mentioned that is that was the driving motivation for the study of the venous system, where we're recognizing that there are adaptations with the arteries in terms of changes in their vasomotor properties. Certain beds, they're constricted more, certain beds, they're dilated more, they're structural changes that may be tied with the fluid redistribution. But then, and then some of the medical conditions that crew are experiencing, like vision changes and an increased risk of cardiovascular risk. But then related with that is the removal of blood from those different tissues. And if there's fluid shifts, and that fluid there's a fluid stasis because there's an inability to transport that fluid away, then it's likely to be driven by the veins and or lymphatics in combination. So this will be a really wonderful opportunity to study that for the first time, investigating multiple organ beds. The venous side of the circulatory system will be adapting.
And so what will be some of the specific methods you'll be doing to assess that?
Yeah, certainly. So as a cardiovascular basic scientist, we utilize rodent models to study non-invasively, but also through ex vivo experimentation of the elements of the cardiovascular system. Non-invasive techniques include Doppler ultrasound, which crew are measuring Doppler ultrasound while they're on station. So that's a technique that has translational potential in terms of the observations that we see in terms of cardiovascular function to tie with crew changes. But then also we do a lot of ex vivo physiological measurements, dissecting and placing arteries, veins in physiological conditions, and testing how they operate, function in different contexts. Those contexts can include different ranges of pressure to evaluate properties like myogenic tone, responses to different biological factors that they would experience in the body, neuropeptides, hormones, as those reagents can affect the structural state of the vessels. And in turn, those allow us to study the steady state physiology of those components, but also if there's an effect by a certain environmental factor. With our studies exploring effects of partial gravity, so these will be some of the first studies exploring microgravity, gravity that crew would experience, similar gravity crew would experience on the Moon and on Mars, and then also importantly sex differences. So with our Artemis program, we'll be sending the first woman to the Moon, and from lymphatics lymphedema research, women tend to be the demographic individuals that are unfortunately affected by lymphatic dysfunction significantly for various reasons. And we're from a space health perspective, we're starting to learn that there are very distinct and very unique adaptations that male and female astronauts experience, but we have much still to learn. Thankfully, we're also sending more women into space, and that involve many more missions. But then we'll also want to do more research to be sure we know what the spaceflight environment, how it affects everyone that travels in space.
And the research has been fabulous because I know they've taken actually rodent satellites where they've engineered habitats. So you launch the rodents into space. They do so many orbits. You bring them back down, and then you do the evaluations, whether it's an autopsy, et cetera, right away. But they survive because then you can see the changes. And then, of course, they've had mice on station in cages, of course, so that and then astronauts I know have also done postmortem exams on station to look in real time how the organs are changing related to those. Is there do you know of any plans to put an actual rodent capsule onto the moon so that you can start to look at some of those components?
That's certainly part of NASA's vision and our, if we were looking at the history of the space biology research from Apollo to now, Apollo missions actually had rodents on board. They had rodents on board, and I believe they're hamsters actually. They did some general studies of biological studies on Apollo. Um, so now comparing to space station now, and space station is a science lab. Now we have so much more capacity to do rodent research than 10, 20 years ago. So we've really established a strong foundation of rodent research on station. That is really a platform for future stations, and then in low Earth orbit or missions to the moon. And with space projects, we think about um, level of complexity. There's different levels of complexity in terms of caring for rodents versus other model organisms. That's a factor, but I'm certain there'll be rodent missions on the moon as well.
So, Sonny, I'm going to ask one last question to open up to John and Emily as we get ready to bring the interview to a closure. And again, thank you for being with us. Your expertise is really exciting to hear about. And I'm just going to toss in a plug for the American Vein and Lymphatic Society meeting that's going to occur down in Miami in September. Sonny has been kind enough to join us. So we're going to be having two sessions in Space Warm and an evening event at Nova Southeastern University, as well as at what's called their Space Dock. So we'll have a good time, and Sonny's expertise down there is going to be really well acclaimed and appreciated. So my final question before John and Emily get a chance to ask their final questions is, if you were to look forward a decade from now, what do you hope that your lab has accomplished in terms of its work and its contributions to the overall mission for human health?
I think I appreciate that question very much. One is more student engagement. I reflect upon my knowledge of lymphatics, and I hope more undergraduate students learn about lymphatics before complete the undergraduate training. So there's, in context of space research in general, I think now we have more people traveling in space than ever before. We have potential more opportunity for space biomedical research. So having more diverse perspectives and contribute to those studies, I think would be fantastic. And secondly is tying more of the space research to medical conditions here. My research with radiation effects on lymphatics started with the observation that there was a paucity of data on radiation effects on lymphatics. There's and it's one of the secondary lymphedema. One of the there's been many correlation studies. So I had the opportunity to investigate how lymphatic endothelial cells respond to radiation from a clinical context, and then thought about how that may be applicable in a space context. But there's still much more to be learned from lymphatic radiation context. But I use that example as a tie between medical research and space research. And with space affecting all organs in the body. There's so many doors, I think, left that have not been seen yet, perhaps, or have not been opened yet, with regards to tying brain adaptations in space to medical condition here on Earth, or other lymphatic conditions to immune conditions, for example. And it's very much my approach would be more interdisciplinary research.
Vein Formula 1000 and Lymphatic Formula 1000 from VitaSupport MD are backed by science and sold in doctors' offices. If you're a physician who may be interested in prescribing or selling these excellent nutraceuticals, please call 862-246-7877 to speak to a representative today.
It will be interesting to compare, and I don't know if there is a study to assess the radiation changes on lymphatic system on our patient population with the different types of cancer treatments, as opposed to the radiation changes when you go up to the moon or with NASA, and compare what are the changes and what structural damage is actually assessed.
Dr. Iker, thank you so much for that question. And yes, I agreed. I speculated Dr. Stan Roxon from in California has done some comparison studies of different clinical radiation effects on the prevalence and lymphedema occurrences. But I agree that those different types of clinical radiation may affect lymphedema development. But then what happens at the basic science level? What happens to the lymphatic endothelial cells? What happens to the lymphatic muscle cells? What happens to the immune cells that the lymphatics transporting in response to those that irradiation effects? And then puts those patients, unfortunately, at a higher risk of developing lymphedema, on top of being exposed to different types of radiation. And then the deep space radiation, that is certainly I have the opportunity to have an ongoing study investigating on, so hopefully I may be able to contribute to that question of yours.
I'm looking forward to meet you in Miami so we can continue the debate.
Likewise, that sounds spectacular.
Interestingly, I saw a patient this evening, the last patient of the night, who had a very, very interesting history. She's in her 50s now, but she had been a professional dancer for many years on Broadway, and really, beat up her body quite badly as a result of her career, which she absolutely loved and adored. And just as you talk about astronauts insisting on going into space and taking certain risks that are associated with that, she felt the same way about her dancing career, loved dancing so much that she knew that she was abusing her body at some point because she was having major arthritic changes, osteoarthritis, et cetera, particularly in her left knee, and had about 5 operations on that knee, including a total knee replacement eventually. And postoperatively, for whatever reason, she is a hyper scar former. And she would lock in this knee with such excessive scarring that she needed numerous arthroscopic surgeries to clean out the knee joint, et cetera. Finally, the knee was replaced with a total knee replacement. And even after the total knee replacement, she scarred in the knee to the point that she had no mobility in the knee. And the reason I bring it up, it's because it's so fascinating. I had never seen a case before, and she claims to be the only case ever done in this major metropolitan teaching hospital nearby, where they ultimately treated her with radiation therapy to the knee to try to decrease this abnormal hypertrophic scarring phenomenon that she had. And it was somewhat successful. And the reason the subject came up, when I was examining her, she has tattoos on her lower extremity, like you would see with mantle radiation for lymphoma. So I recognized those those tattoos from my thoracic surgical days and asked if she had radiation to this knee and was there malignancy. Of course, there was no malignancy, etc. So again, bringing it full circle, it was a very fascinating clinical case. We have to keep in mind also, I think, as scientists, and I'm sure someone of Sunny's esteem is doing so, we're kind of thinking about the discussion tonight anyway has been focused mostly on the potential negative aspects of this GCR on the human body. But we have to keep our mind open to the fact that there could be potentially some positive aspects in one area of the physiology or another, just as radiation is used effectively to kill malignancies, and in this case was used, it seems, quite effectively to decrease hypertrophic scarring. Let's keep our fingers crossed that there may be some unknown positive component to the GCR that we're not yet aware of, and who knows, maybe Sunny has already thought of some of those potentialities.
Thanks, John, for that observation. We are still in the context of space research, still really contextualizing the observations, whether they are positive or negative, and central to that will be having more people, which we are, having more people travel in space, and having more researchers explore the adaptations from different perspectives. There may be, and this goes back to our earlier conversation with regards to discovery and innovation. There certainly may be new pathways or new biochemical processes or physiological adaptations that are positive. Maybe even could be translated in the therapeutic options. But we're really at the tip of the iceberg, and we're also reaching. Thankfully, the International Space Station is a dedicated science lab, and will be a science lab, so we can really dive into those kind of specific contextual knowledge in much more granularity than ever before.
Great information. I, as a non-scientist, really enjoyed it. I gained a lot of information tonight, so thank you, Sunny. We want to thank from California, Dr. Emily Iker. Dr. Iker, thank you for everything.
Thank you to all of you, and what a fascinating topic we had today. Sunny, thank you again, and hope to meet with you in person in Miami.
All right, very good. From Minnesota, Dr. Mark Melin. Dr. Melin, thank you very much, sir, for everything tonight.
Well, thank you. And, Sonny, I want to thank you because I know it takes a lot of personal sacrifice to do this kind of work. It's a lot of Friday night, Saturday night, sitting in the library, a lot of reading, a lot of theorizing. You're driving down the road and you're thinking about stuff that's going to occur in 7 years today while we're thinking about stuff that's going to occur today. So, thank you for your vision, your wisdom, and your willingness to educate and bring teams of people together that are going to make healthcare better in the long run. So I look forward to seeing you in Miami. And thank you for your time today.
Guys, really a pleasure, and thank you so much for the opportunity to meet with you all and share. And health to me is very much about people, so I appreciate the opportunity to meet more people in the community and have these wonderful conversations. Think about how space can advance and progress our healthcare research too. Appreciate the opportunity.
All right, thank you very much, Sunny. The founder of Vita Support MD, makers of Vein Formula 1000, Lymphatic Formula 1000, the founder of this show, physician surgeon from New Jersey, Dr. John A. Chuback. Dr. Chuback, thank you for everything.
Thank you, Paul. I'll just wrap up by saying two things. One is, if I ever get an invitation, a ticket to fly on the parabolic jet, Mark Melin can have my ticket. I won't be attending. And secondly, I would say that as astronauts go out into space, I'm the exact opposite. I'm so down to earth, I'm practically subterranean. So if there's ever the journey to the center of the earth, I'll probably be on that mission. But I have such great admirations for not only the astronauts, but the scientists, the engineers, and all the great minds who come together, administrators, et cetera, to put that NASA program together, both nationally and with private enterprise now. It's really quite impressive and remarkable. So thank you very much for the good work you've done, Sonny. And it was a great pleasure meeting you, and I'm sure we'll all meet again soon.
All right. Now go ahead, Sonny. If you have a final word of wisdom, go right ahead.
It's always great to chat, research, and hear the different perspectives, and this conversation also sparked new ideas and inspirational thoughts to move forward. And I look forward to meeting with you all in Miami later this year.
All right. Thank you very much. And we thank you, the listener and the viewer, for watching and or listening to tonight's LymphCast show, episode 17. We'll see you next time for episode 18. Until then, have a great day. We'll see you next time for LymphCast.